While we are all joining this event from our own location, we would like to acknowledge that we are meeting on the lands of the Wurundjeri people and the Boon Wurrung people of the Southeast Kulin Nation. We would like to pay our respects to their elders, past, present and emerging, and to all First Nations communities joining us today.
Mount Bennett Observatory is a community-run astronomical society in the Dandenong Ranges. We are completely volunteer-run and have over 500 members. We focus on community engagement, outreach, diversity, and helping our members to get the most out of their love of space and astronomy. The observatory was originally built by Monash University for students to do astronomical research, especially on variable stars whose brightness changes over time. Over the next 2 decades, the site was expanded and upgraded, but eventually took a back seat to modern giant internet-connected observatories around the world. In 2011, our 5 founding members reached an agreement with the landowners and took over the lease and established the society. Now, we run over 80 events each year, including members' nights, public viewings, and special events. We have several special interest groups including deep sky observing, radio astronomy, astrophotography, astro arts, and young observers. In 2020, we expanded our online presence and now host regular live streaming events. We welcome all new members and love making new friends with other astronomy lovers. You will be joining a friendly community of passionate, hard-working amateurs who have a grand vision for the future of the observatory. We hope to see you up at MBO soon.
Welcome everyone, either from Australia or overseas, to another night at the observatory. Tonight's stream is unique because not only are we bringing to you live the lunar eclipse, we are also streaming this segment to our friends in Russia. Privet Kagzala from Australia. Before we begin, I'd like to give you a shout out, as always, to our fabulous crew who are working hard behind the scenes and are on Facebook and YouTube tonight. They too play a big part in bringing this production to you. We also have Adam, who is my technical operations person for this evening, and we have Anthony and Tony out at MBO, along with Neil and Steve, who are both at different locations around Victoria, set up with telescopes ready to bring to you the fabulous moon tonight. I'd now like to introduce to you our panelists who will be presenting this evening. As you all know, we at Mount Bennett Observatory encourage people from all walks of life to join us, and tonight is no exception. For tonight's stream, we have some special guests joining us on the panel. Our first guest is Pavel, a member of MBO, and our other special guest joining us all the way from Russia is another Pavel. And of course, we also have Andrew, Drew, and Jackie from our wonderful regular presenters speaking tonight. As you can see, we have minimal panelists this evening, including myself, Petra, your host, and this is because our stream takes on a different arrangement. This stream is approximately a 4-hour stream, the full length of the lunar eclipse. The majority of the stream will be about giving you, the public, opportunities to ask us questions while you're observing the lunar eclipse, and we will attempt to answer them all, as we also have the rest of our wonderful regular panelists available to rocket in and answer some questions. And this includes our friends in Russia as well. We ask you to ask questions. That being said, we also want you to not only be observing the lunar eclipse from your devices, but we want you to be part of this experience. And what I mean by this is we would like you to have the opportunity, weather permitting, to go outside and have a look at the lunar eclipse during all its phases. And then If you would like to, you can either take a photo or draw a picture of what you see and send it in to us at this email, lunar.eclipse@mbo.org.au. Our plan for tonight is to display some of these wonderful images that you send to us during our stream. And of course, please make sure that you continue to ask questions. There will be 3 planispheres given away tonight, one for the question of the night, one for the photo of the night, and one for the picture of the night. And these winners, along with some other notable images and drawings, will be posted on our MBO pages. So let's get started. And first up for tonight's show, we have Pavel in Russia, who will be speaking to us about lunar and solar eclipses along with Siberian astronomy.
Hi everyone for watching this event. Can you hear me, please?
Okay.
Hi everyone. Can you
Hi,
hear me?
Pavel. Yes, we can hear you, Pavel.
Okay. Hi everyone for watching this event. We send our warmest greetings from the northern hemisphere of our planet, from Irkutsk. Thank our colleagues from Mount Bernard Observatory who has granted us the opportunity to take part in this event and thus to show our Russian friends this particular astronomical phenomena, total lunar eclipse. Our region is worldwide known for the unique vehicle, and it also holds a record for the number of clear sky days and nights per year. Irkutsk Regional Astronomical Organization and Irkutsk Planetarium unites meta-astronomers of the regions and conducts sidewalk astronomy night throughout the region on a regular basis since 2007. Our goal is to give an opportunity to show the night sky to the most amount of people. We believe that this experience changes a person and society as well. Supported by International Astronomical Union, we fulfill the project Telescopes for Siberian Villages by granting telescopes to the remote parts of the region, making the conditions which form the astronomical clubs and societies on the territories. In Irkutsk, people visit planetarium and astronomical observatory in city center. Within 2 weeks from the lunar eclipse, there will be an annular solar eclipse on 10th of June. We also invite all viewers to our stream on 10th of June for the partial solar eclipse in Irkutsk. And for now, ask questions and make comments to us on the chat in Russian or English. We will try to answer you. We wish all of you good weather for this event.
Thank you, Pavel. I'm very honored to have you here. Okay, don't forget, if you have any questions, like Pavel said, to drop them into the comments. And if you like what you see tonight, make sure you hit that like button or that subscribe button on YouTube, which is free, and follow us in future. Our next presenter will be Drew, and Drew will be speaking to you about the stages of the eclipse.
Hi everybody. I'm going to talk a little bit about lunar eclipses and what we're going to see tonight. Firstly, let's talk about what's involved with the lunar eclipse. Something very important is the sun, without which we wouldn't see very much. We also have, of course, the Earth, where we are. Now, the sun shines on the Earth as the Earth revolves around the sun, but the Earth carves out a part of the sky where the sun's light is blocked. We can see my drawing here, where there's this region behind the Earth that is in the shade of the Earth all the time. This area moves, and this area we call the umbra. Now, there's also an area to either side of that where partially the sun is blocked. If someone was in those triangles there, they could see a bit of the sun, but not all of it. This area is called the penumbra. These are both important in eclipses, as I'll show you shortly. Now, the third part that's very important here is, of course, the moon.
Hello, Drew. Just can I stop you there for a minute?
Yep.
I do believe you should be sharing your screen. Is that right?
I'm not sharing my screen. Okay, I'm.
Yep. Because I know your information is amazing, and I would love for our viewers to see it.
Yes, my apologies, everybody, on that. Let me just share that and
Fabulous.
try again. Okay, can we see that? Hope we can. So, lunar eclipses, let me fast forward. We have the sun and we have the Earth, and we have the area that the Earth blocks. Now, the area that the Earth blocks is called the umbra. There's an area that's partially blocked, and that we call the penumbra. Now, we have the moon, which travels around the Earth as the Earth travels around the sun. And the moon is actually angled at about 5 degrees from the ecliptic, which is the plane that the Earth and the sun are in. So it doesn't always line up perfectly with the Earth and the sun. That's why we don't get an eclipse every time the moon goes around behind the Earth, because it's usually slightly above or slightly below. But sometimes it does line up, and it's doing that tonight. Now, the moon travels around behind the Earth, and it does so. It enters the penumbra. This gives us a penumbral eclipse, which is not overly spectacular. The moon is dimmed a little bit, and you might not otherwise know differently. 1 in 3 lunar eclipses are penumbral only, so they're generally not that spectacular. But the others become partial, or, as we have tonight, total. Now, the moon travels through the penumbra, and as it starts going into the umbra, we can see it starts getting blocked by the Earth, and the round disk of the Earth starts to cover the moon. Sorry to the flat earthers around, if you're out there. This is due to the Earth's spherical shape. The moon keeps on going through, and we can see as it is almost all in the umbra, it's almost completely blocked out by the Earth. When it's this close, it's just a slight sliver. Now, we can't really see it, but the moon is actually reddening a little bit there. And when it gets to a certain point, we see it majorly. As it starts to enter the umbra in full, we have this reddish glow on it. The reddish glow is due to the fact that it's behind the Earth, and what we're actually seeing there, that red area, is where light is only getting to it through Earth's atmosphere. So just as our skies are normally blue, when the moon is in the umbra, that blue light that we would see in the sky is not going through to it. Instead, we see refraction like we do a bit at sunset and dawn, and we get the red sky, we get the red moon. It gets completely into the Earth's umbra, and this is a full-on total lunar eclipse. It looks very, very bright there, very bright red, but it's actually a fairly dim red. It's just that at this point, the moonlight that we would normally see is no longer there. So it's a bit more distinct. So the moon goes through the penumbra, and we have a penumbral eclipse. It goes into the umbra, and we get a partial eclipse. And if we're lucky enough, then we get, as we will have tonight, a full total eclipse. Of course, as the moon proceeds from there, it goes through and keeps going through, but it's basically the reverse of going into a total eclipse. And what we have at the moment is a penumbral eclipse outside, And as the night goes on, we will get to a total eclipse. There'll be other speakers and other things happening, but I fully encourage you. I think it's a bit after 9 o'clock when we do get to a total eclipse. Please go outside and look at it because it's very beautiful. On that, I will finish. So thank you all for paying attention, and my apologies for not sharing at the start. Thank you.
Thank you, Drew. I think our audiences will have a better understanding of what penumbral and umbral phases are now. Next up, we now have Andrew showing you what the lunar eclipse looks like on Redshift. Sorry, Andrew, you were just on mute. Could you please unmute?
Sorry, I knew I'd do that. There we go. Hello again, everybody. Welcome. Yes, you can see what Redshift is virtually indicating would be the start of a lunar eclipse. This is the view from the Earth. If we view back a bit, there you can see there's other stars around it, okay, up above there. But and you can see where it is in the sky near the constellation of Scorpio or Scorpius. Let's just go to the moon though and see what it's like looking back at the Earth. Let's go to the moon. Off we go. Coming in, we're going to have a look around. And the dark side, there's the sun in the distance. We'll just let this finish. There we go. Now let's just sashay around a bit and look back towards the sun and the Earth. There's Venus and Mercury. There's the sun and the Earth indicated by labels, but we're looking at the back part of the Earth, so it's dark, and we can just see the sun showing there. This is from one side of the moon. So at the moment, there's a little bit of sunlight getting through. If we looked from the other side, just to get a better idea, you can see that's a lot more sunlight getting through there. So one side of the moon is going to be darker than the other, but it's not completely cut off yet. All right, but there's the Earth in the way. And again, if we go around to the other side again, there we can see what I'm talking about. Quite dark here because most of the sun is being blocked by the Earth, but around here we've still got quite a lot of brightness. If you were to go outside now, and I encourage you to do that, if you've got some clear sky above you, you will see that this is the case. The colours may not be the same. This is all computer enhanced, but you should be able to see one side of the moon brighter than the other. I'll just go back to Earth. And back we go. There we are. We can see Perth's just getting dark. So you people over in Western Australia should be able to see the moon now. If you look to the east, as long as you can see the horizon. Here in Melbourne, the moon's quite high now. It's been up for 2 hours. At that point, we'll go back to Petra. Thank you.
Thank you, Andrew. Redshift is always helpful and allows us to see things at locations in the night sky, especially we don't have a telescope. Okay, everybody, now would be a good time to pop outside and see if you can see the eclipse in its penumbral phase. Maybe take a photo or two and come back and ask any questions or draw a picture and send it in to us at lunar.eclipse@mbo.org.au. We'll see you shortly. Hello, we're back. Some of you have been asking, where do we go? Well, we're still here, but we want you to go outside and have a look at the moon if there's clear skies. If you don't have clear skies, we'll be popping, as you can see, the moon on your screen so you can see it from our telescope and enjoy it from your devices. We just like you to reflect and enjoy the moon for a few minutes. So some of you may have noticed that the moon is now moving into its umbral stage. So we are going to have next up is Pavel from MBO explaining why we see the eclipse different from the northern and southern hemispheres.
Good evening, ladies and gentlemen. I would like to welcome everyone who is watching our live stream devoted to the total lunar eclipse. Добрый вечер, дорогие друзья. Я приветствую всех, кто смотрит наш выпуск, посвященный полному лунному затмению. Затмение уже началось, и те, кто смотрит на северном полушарии, вероятно, уже обратили внимание, что Луна выглядит необычно, как будто перевернутая. А ведь мы в самом деле видим Луну именно так. Сейчас я постараюсь объяснить, почему это происходит.
Как известно, в мировом пространстве нет ни верха, ни низа, но люди еще в древности определили стороны света – север, юг, восток и запад. За основу было принято, что небесные светила восходят на востоке и заходят на западе. При этом Земля вращается вокруг своей оси с запада на восток, делая один оборот за 24 часа. Аналогично географическим сторонам света обозначаются направления в пространстве и на других планетах. В частности, Луна вращается вокруг Земли в том же направлении, что и сама Земля, то есть с запада на восток, делая один оборот за 27 с небольшим суток. А сейчас давайте посмотрим на расположение Луны во время затмения с точки зрения земного наблюдателя. Для наглядности повернемся так, чтобы вверху был восток, а наблюдатели в северном и южном полушариях были в примерно одинаковых положениях. Но чтобы северный мишка увидел затмение полностью, давайте переместим его дальше на восток по той же широте. Например, на Алиутские острова на севере Тихого океана. Итак, оба наблюдателя смотрят на Луну, у которой север и юг расположены так же, как и у Земли. Мишка, которая на севере, смотрит в южном направлении и видит Луну в южной части неба. При этом восток у него слева, а север Луны он видит вверху. Кенгуру из южного полушария смотрит на север и видит Луну в северной части неба. При этом восток у него справа, а Луна ему видится обращенной кверху своим южным полушарием. Таким образом, получается, что для южного наблюдателя Луна кажется вверх ногами по сравнению с тем, что видно на севере. Теперь давайте посмотрим, как выглядит лунное затмение из разных точек земного шара. Именно так видел бы затмение наблюдатель, находящийся на экваторе. Луна движется почти вертикально, пересекая земную тень сверху вниз, что соответствует орбитальному движению с запада на восток. Мишка на Алиутских островах видит, что Луна пересекает земную тень справа налево, но при этом орбитальное движение неизменно происходит с запада на восток. А вот австралийскому кенгуру будет казаться, что Луна пересекает земную тень слева направо, хотя по орбите она движется все так же с запада на восток. Теперь посмотрим еще раз, что видят наши наблюдатели в одно и то же время. На этом слайде наглядно видно, что лунное затмение выглядит по-разному в разных частях света. Но и это еще не все. Нельзя не упомянуть такое понятие, как параллакс. Дело в том, что наблюдатели, находящиеся в разных точках Земли, достаточно удаленных друг от друга, видят Луну на фоне разных звезд. В этом примере Мишка видит Луну на фоне красной звезды, а кенгуру на фоне голубой. Угол между этими двумя лучами зрения и есть параллакс. Практически он равен углу, под которым с Луны виден отрезок соединяющей точки, в которых находятся наши наблюдатели. Посмотрим, как выглядит это на практике. Из Мельбурна мы видим, что в начале затмения Луна проходит недалеко от звезды Нью-Скорпиона. Отметим положение Луны угломером и измерим угловое расстояние до этой звезды. В то же самое время наш Мишка на Алиутских островах видит Луну в совершенно другом месте, на линии, соединяющей Альфу и Бета Скорпиона. Наш угломер остался на месте, а положение Луны, видимое из Мельбурна, отмечено красным кружком. Измерим угловое расстояние от него до нового положения Луны и получим около 1,5 градусов, что равно 3 лунным дискам. Это очень заметная для невооруженного глаза разница. Таким образом, мы наглядно продемонстрировали влияние параллакса на то, как Луна смотрится на фоне звездного неба с разных сторон земного шара. Несмотря на все эти различия, зрелищность лунного затмения не зависит от географического положения наблюдателя. И не зря оно считается одним из самых красивых астрономических явлений. Спасибо за внимание. Thank you.
Thank you, Pavel, for that educational information in both Russian and English. We now will have Andrew again to show you on Redshift why we are seeing the eclipse and Russia is not. You're just on mute again, Andrew. We would love to hear what you're saying.
Gee, I only just muted myself. Oh, well, there we go. Lovely live streaming is wonderful, wonderful, wonderful. Here we are. This is looking back to the Earth from outer space in current time. You can see the time at the bottom there, Eastern Standard Time. And you can see there the line of the edge of the shadow of the Earth. So the sun's in this direction. That means that here in Russia, it's still shining, right? The sun's about to set in eastern Russia. You people in Perth, the sun's gone down. You're probably just a little bit in darkness. And all through the Pacific, it's darkness. And they'd be looking just about straight up to see the eclipse at this time. So most of the world's not seeing it. There's just a few islands in the Pacific and all of Australia and New Guinea watching this at this time. This is because, of course, this time of the year, it's summer in the northern hemisphere. So the Earth is tilted 23.5 degrees towards the sun. And the North Pole is in light all the time, whereas the South Pole is in darkness all the time. So I just thought that might show for you why Russia is actually going to miss by the time that this shadow line comes right across to Russia, the eclipse will just about be over. So we're very fortunate we can see it here in Australia. Back to you, Petra.
Thank you, Andrew. Okay. We would like to now have some questions answered. And this one comes from Cameron, and it's for Jackie. Is a lunar eclipse a common event?
Hi. Okay, so lunar eclipses are actually there's more solar eclipses than lunar eclipses, believe it or not. So if you put all the stats together, you actually get more solar eclipses than lunar eclipses, which seems a bit weird because we see more lunar eclipses than we see solar eclipses. And that's because the whole half of the world can see a lunar eclipse at one time, but you have to be in a pretty precise spot to see a solar eclipse and notice it happening. So I suppose in a way lunar eclipses are rarer than solar eclipses. And I was looking at the stats for the next 10 years just before this presentation, and we're not actually going to see that many total lunar eclipses in the next decade. which did surprise me. Now we'll see some partials and some penumbral eclipses where the moon only passes through the penumbra of the Earth's shadow, so we will get those. But we won't see too many total lunar eclipses in the next decade. That's just the way it works out. Sometimes you get a whole lot altogether, sometimes you don't. It's like, I suppose, that saying with you wait forever for a bus and then you get 3 in a row. That's kind of what happens with lunar eclipses as well. So I suppose you could say in one way they're rare, and in another way they're not, because they're nighttime and we get the chance as a whole half of the planet to see them. They're not, in a way. So it's a case of half and half. There we go.
Thank you, Jackie. While I have you there, this question has also come in from Cara, and they have asked, are all total eclipses red?
No, actually not. Now, the colour of a lunar eclipse is different for each event, and it depends on the state of the atmosphere. And what can change the colour of the eclipse is how much dust and gas from volcanoes has been thrown up. So it's been a while since we had a really big volcanic eruption, which really has changed the Earth's climate. And the last big one we had, which changed the Earth's climate and dropped the temperature by a couple of degrees, was Mount Pinatubo in the early 1990s. Now, who's old enough to remember that? I often ask this, and people sort of look at me and go, I know you're old enough to remember it, and I'm not that old, and I remember it really, really well. Mount Pinatubo put a lot of sulfides into the atmosphere. We had beautiful crimson sunsets for a couple of years. I remember the winter sky being very milky and opaque, and the global it's the last time the global temperature really dropped. And for 2 lunar eclipses in a row, for about over about the space of a year, the lunar eclipses were dark grey. They didn't go red at all. The atmosphere blocked too much light getting around to the eclipse. So there was actually dark grey in colour. I didn't see the first one because it wasn't on our side of the world, but the second one was in June, and I remember it so distinctly. Now, there is actually a scale which describes the colour of eclipses. It's called the Danjon scale. That's Danjon. The Frenchman also is famous for another thing to do with the moon as well. But if you want to look up the Danjon scale, that describes the colour of eclipses. It goes from a light red all the way down to the moon being almost invisible in the sky, which can happen if a volcano throws up an enormous cloud of dust. Think Mount Tambora in history. It could happen. It's just that we've had a long time between really big volcanic eruptions. So our human memory being short has forgotten it can happen. But you never know. Next 10 years, 20 years, it might happen again. So you might see it. So we've been treated to a lot of really sort of pale orangey red eclipses in the last 10 to 20 years. So we've all forgotten about what can happen with the colour of eclipses up there in the sky. But watching lunar eclipses is actually a really good way to keep track of what the atmosphere is doing. So thanks, Petra. Back to you.
Thank you, Jackie. So keep bringing in your questions, because we will rocket our presenters in to answer them for you. I'm wondering now, Adam, can we pop up some pictures that have come through from people? That would be really good for them to see what pictures we've been getting. Okay, Adam's going to bring up our first image shortly, and that is from Alexandra, who is 14. I'm seeing this picture. Oh, wow. Can we pop that up again? That was amazing. Okay, while Adam's still collating our pictures together to bring them up, keep your questions coming in. I'm going to bring Andrew on the screen, and he's going to answer a question about, is there water on the moon?
Yes, well, I hope you can all hear me this time. Yes, there is. Recently, there was, I think it might have been a Chinese probe that went to the moon, and there was an article in a recent magazine from Australia that showed it, excuse me, a very clear picture of one of the craters on the moon, and inside the crater was ice, and apparently it's quite deep. So yes, there is water on the moon, only as ice, and there's certainly not a lot. But it means that if we did establish some sort of colony there, there is a source of water. There may also be some water under the ground, trapped within the crust of the moon. So it shouldn't be a problem. If we can melt it, we can put it in a tank and we'll have water to drink. More importantly, we'll also have water to make hydrogen fuel and oxygen to breathe. So there you go. Yes, there's water on the moon.
Fabulous. Thank you, Andrew. While I've got you, we're going to ask another question. Why are there so many craters on the moon? Because as you can see in our pictures, we can see all these craters. So why are there so many of them?
Okay, well, again, I think there are two main reasons. I might need backup from Jackie here, but I think there are two main reasons. One, there's no atmosphere. So whereas most of the meteors that come towards the Earth are small and would burn up in our atmosphere, there's nothing to do that on the moon. So anything that's going to hit the moon is going to hit the moon. There won't be anything to stop it. And secondly, the Earth has actually had millions of impacts from meteors, but we can't see them anymore because we've got an atmosphere and we've got rain and we've got erosion. There are only a few craters on the Earth, large ones, that are still apparent, impact craters, whereas on the moon, every crater that was ever formed is still there. There's been nothing, no wind, no rain, no snow, nothing to wear it away. So that's the main two reasons that I would suggest. You could back me up there, hopefully, Jackie.
Yeah, and tectonic plates carrying things down on the Earth, taking them away. Yeah, so it's really interesting to look around the solar system, and anywhere you look and there's no craters, you immediately want to sit up and say, what's going on? And so when New Horizons flew past Pluto and they saw a great big clear patch with no craters on it, they went, wow, there's something going on there, and we thought it'd just be this icy ball covered in craters, which means that it had been dead since the beginning of the solar system. And they went, wow, this has been like active at least in the last billion years. And they went, that's just amazing. But even just like closer to home, things like Europa, which is very famous for having an ocean under the ice, and there is a mission plan to go there. It's called Europa Clipper. Enceladus, the moon around Saturn, is missing a lot of craters. We know there's active jets of salty water coming out of that. Of course, Mars with its winds across it. Where else are we missing craters? There's quite a few places. The craters are missing, or they've been moved or shifted. So where you see very smooth places in the solar system, you wanna sit up and ask questions. Yeah, and that's actually how they date bodies as well. is by looking at the craters and how much overlapping there is. So craters are really, really useful.
Yes, the moon's got craters within craters, so been around a while. Yeah. Thanks, Jackie.
Thank you, Andrew and Jackie. Now we have a question. It is asked, and it's going to be for you, Jackie.
Mm-hmm.
When is the next solar eclipse in Melbourne? So not lunar, but solar eclipse in Melbourne.
Oh, solar eclipse. Oh, I got all my lunar eclipses ready.
No, when is the next solar? Kylie is asking when the next solar eclipse is in
solar
Melbourne.
eclipse. Okay, so actually this December there is a tiny little partial eclipse. Actually it's the 4th of December. Actually, I've got my book here. Yeah. But only like a tiny bit of the sun is going to be covered, like a couple of %. So if you're just walking around, you won't notice it. You will only know it's happening if you actually know it's happening, and you've got some specialist equipment to look at it, because it's dangerous to look at the sun at any time, and even with equipment. So and I think it's happening right at sunset for us as well. So it's this really, really awkward event. The next best total solar eclipse is actually happening over Sydney. The whole of Sydney is going to be covered in July 2028. That's the big one to mark on your calendar. And the next one to go over Melbourne's quite a way over that. I can't remember off the top of my head. There are some solar eclipses coming over Australia in the next 20 to 30 years. So if you're prepared to travel, yes. The next one that's actually hitting the Australian continent is actually 2023 at Exmouth. So unless you're a really, really keen eclipse chaser, I don't know how to go to that one. But 2028 in Sydney, yeah, there will be lots of opportunity for that. It's going to cover a large part of the continent, and like 4 million people just need to step out of their house and look up, and they'll get a fantastic show. Yeah. Plus the other 4 million people are going to probably fly in and try and join in. It'll be a party.
Fantastic. And while I've still got you, yes, now Cameron again has asked, when is that next one going to happen? I presume they're talking about our lunar eclipse.
Oh, yes. So there's a partial, now have I got the right one? Partial lunar eclipse in November, which we're going to, I think it's a sunrise one for us, so it's low in the west. So that's November the 19th, and then it's a whole year before we see the next one at the beginning of November. So there are some coming along. So November's the next one in the morning. We're just lucky this one's really conveniently placed mid-evening. They don't always work out that way.
Yeah.
Sometimes they do.
We certainly are really lucky this time round.
Mm.
Okay.
Can I just remind people too, that Pavel mentioned earlier in the stream that there's an annular solar eclipse in Russia that we hope we're going to pick up their stream to us, so we'll be able to see it live here. Annular, meaning that the moon doesn't completely blot out the sun, so it's not really that safe to look directly at, but you get a ring of the sun showing around the edge of the moon. It should be spectacular.
Yeah, so that eclipses always come in pairs, and it's known as an eclipse season, or sometimes you get 3, but usually they're pairs. So what's happening is this eclipse is when the moon is at its closest point in its orbit to the Earth, so it's at perigee, and then as it swings out 2 weeks later, it'll be what's called apogee, its furthest point in its orbit to the sun, so it'll be too far away from the Earth to actually cover the sun. That's why it's going to be an annual eclipse and have that ring around the sun. And it just so happens it'll actually the path will cross the North Pole, and our friends in Russia, they're going to see the partial phases of this eclipse where they are. Yeah, so it crosses from like Canada over the North Pole and the Arctic Ocean and like all of Europe, and a lot of Russia will get to see the partial phases. And then 5 months and 10 days later, we'll have our next season, and that's when we have the next lunar eclipse, and we have the little partial solar eclipse that I mentioned on the 4th of December. So, yeah.
Very good.
Excellent. Thank you to you both. I am now going to ask Drew to come on screen with me, because we have a question from Max, which asks, Max wants to know, if he was standing on the moon on the dark side, would it be completely black on the ground there?
That's a great question, but firstly, let me reiterate what the dark side of the moon actually is. The dark side of the moon is on the opposite side of the moon from the Earth. So it's called the dark side because we don't get to see it. The dark side of the moon is not actually dark, however. The sun shines on it just like it shines on the rest of everything in the Earth-Moon system, and the sun appears to move through the sky there. But if you're standing on the dark side of the moon, you never get to see the Earth. Now, at the moment, the Earth, so the sun, the Earth, and the moon are all basically in one line from each other. So when you're on the dark side of the moon, if you're on the dark side of the moon at the moment, then not only would you not get to see the Earth like you always wouldn't, but you would also not get to see the sun at the moment. And so consequentially, it would actually be very dark on the dark side of the moon at the moment, because you can't see anything further in.
Thank you, Drew. And while I have you there, we also have Jack, who's asking, he would like to know, why does it only affect the moon and none of the stars in the sky?
Yep. So here on the Earth, we like to think of ourselves as the center of everything and everything in relation to the Earth. But the Earth is a pretty tiny part of the universe. We have the moon, which orbits around us. It's quite a long way away, but in astronomical terms, it's very close. And because the Earth is a fair bit bigger than the moon, we see the drastic effects of the lunar eclipse, where the Earth completely blocks out the sun getting to the moon. And we're getting towards that point now. If you look at the moon now, you can see it's mostly covered by the Earth's shadow. But the moon is very close and it's very small in the scheme of things. If we were to think about Jupiter, sometimes Earth gets between the sun and Jupiter. But because the Earth is so small and the sun and Jupiter are very big and the distances involved, you would have to have a telescope at the very best and a very powerful one to see the Earth's shadow on Jupiter, because it would be so very tiny. Now, when we extend that to the stars, which are not only a very long way away, but are also so much bigger than the Earth, mostly. Some are fairly small, but most of them are quite big. The Earth means absolutely nothing in astronomical terms. So from another star, you would see the sun as a dot in the sky, but you wouldn't see the Earth, and you would have no idea that it was getting between you and our sun. So whilst we think of everything as being Earth-centric, for someone from another star, we would be nothing to them.
Okay, thank you, Drew. And just one more question while I'm waiting on some pictures to come through. This one is for you, Jackie. Natalia would like to know, how long will it last for? And I think what she means is, how long will our lunar eclipse last for?
Oh, okay. Well, the one tonight, it's going to go until 10 to 12. So, but the main show is actually quite short. It's just going to skim through the shadow of the Earth, and it's only going to last for about 20 minutes or so. So from, let's say, around about 10 past 9 to 9:30. Okay? So you only need to stay up until 9:30 to see the main event. Okay? So that's not too late. Can you make that? I know it's a school night. Yeah, so as long as you stay up that late, that's the main thing you can see. And after that, it just sort of repeats all the things that it's doing now. But that's just skimming through the edge of the shadow. If we had a full event where the moon went right through the center of the Earth's shadow, and we went from woe to go where it just touches the edge of the penumbra and it goes right through the middle and all the way out there, it might take up 5 hours. And going through the full shadow of the Earth, it might take over an hour. Okay, so it's really, really slow. It's like it's almost like watching paint dry and grass grow. And that's why I always recommend for watching eclipses, lunar eclipses, and for watching meteor showers, get some friends. Have a party because it doesn't happen fast. It's a little bit faster than snails crawling, but yeah, it's not a speed event. This is one thing that happens slowly up there in the sky. There you go.
Indeed, it does.
Yeah.
It looks slow, but the moon's actually belting along at thousands of kilometers.
Oh yes, it does change. Yeah, but it's not sort of blink and you miss it kind of thing. Yeah.
Very good.
Okay, thank you so much. I might get Andrew to answer one more question.
Mm-hmm.
Andrew, is there life on the moon?
Okay. All of us with imaginations and everything would love that to be true, but it would appear the answer is no, but not as we know it. Proof of that, we can go right back to the 60s when our first astronauts went to the moon and walked around on the moon. When they came back, they weren't allowed to go to ticker tape parades and all that sort of thing because at the time we didn't know the answer to this question. So it is possible, we already knew, by the way, that there's maybe some form of water there. There may be, there's probably no atmosphere, there's no gases anything can breathe. So for anything to live there, it would have to be something that doesn't require air. So they thought there might be anaerobic bacteria because we do have some of those on Earth. So when the astronauts came back, they had to go into quarantine and be isolated from everyone for quite some time because that question hadn't been answered. Nothing grew on them, nothing appeared symptom-wise. They didn't go turn into lunatics, nothing happened. So it was clear they didn't bring anything back with them. There was no sign on the spacecraft or anything of any form of life. So at this stage, we are of the opinion there is no life as we know it on the moon. There you go. Oh, there were some weird stories in history, though. Years ago, I read a book called Our Incredible Spaceship Moon. I don't know whether it's still around, which claimed that the moon is actually a spaceship. It's hollow. The entry to it is on the far side, and that frequently UFOs come pouring out of there and head to Earth. I don't think it sold a lot of copies, and I don't think it's still around. So no life on the moon. Thanks for the question.
Thank you, Andrew, for answering that. Jackie, this one's for you while I have you here. The question is, it's from Tarini, and they want to know, when was the first eclipse recorded?
Well, the first one, when I saw that question, I thought about there's a clay tablet from Babylonian times with the cuneiform in it of them recording an eclipse in Mesopotamia. Okay, and this is a really important tablet because of this observation, we can actually work out how much the Earth has slowed down in rotating, and we've got an idea. Because if you imagine we just go backwards in time and we think the Earth hasn't changed its rotational rate, the eclipse that they saw should have happened over London, over Britain. And the Babylonians shouldn't have seen the eclipse at all. But the Babylonians, they gave us our system of time because they loved the number 60 and all the ways the other numbers can divide into it. And they would record their timings in units of 6 minutes, basically. So we know down to a matter of 6 minutes when they saw this eclipse and on what day. And from that, we can work out how much the Earth slowed down from today to about 3,500 years ago. And so we know the Earth roughly slows down about, I think it's a thousandth of a second each century. But it's not even. The Earth doesn't slow down evenly. It speeds up, it slows down, earthquakes knock it one way, the atmosphere expands during El Niños, slows it down, and then it shrinks again and it speeds up. So the slowing down of the Earth's rotational rate is not an even process. And even though we're talking about predicting eclipses, we can predict roughly where they're going to be in the future. But you'll still find, and I know I can go online and they'll be putting maps on there, but you'll find that you really won't get it very precise until you get within about 2 years of that eclipse happening, because until you know what the rotation of the Earth is and how much time has slowed down in between that prediction and up until the point where you are where that eclipse is about to happen, you won't be able to get your location exactly precise within maybe a kilometre or so. So you might be out. So if you want to stand on the edge of the eclipse, you just might miss it because it might just shift a little bit because the equations are just slightly out because the rotation of the Earth wasn't just quite right. So these days it's getting better and better, but 20 years ago you never ever saw path locations until at least 18 months before an eclipse was going to occur, because they could never be sure about the rotation of the Earth. They had to wait. So it's but that as far as I know is one of the earliest and best observations of eclipses that have been seen. But we also know they've been observing eclipses, civilizations, for thousands of years, because they have known for at least 10,000 years, probably more, how to predict at least lunar eclipses, because it's just a matter of simply counting. Well, Petra, can I keep going? Yeah. Okay, because this is how you work out how to predict an eclipse. Okay, you've got to basically keep track of all the eclipses you see over. Okay, 18 years, 11 days, and 8 hours. Okay, because that's how long it takes the moon to return to the exact same spot in the sky where it was before. Because we know that the moon's orbit is tilted by 5 degrees, and it keeps changing. So every 18 years, 11 days, and 8 hours, it returns to the same spot in the sky. But 8 hours, that's a interesting figure, isn't it? 8 over 24, that's a third of a day. Okay, so let's repeat that by 3 to make up a full day. So let's do another Saros. So the Babylonians called that sequence a Saros. So we'll record all the eclipses we can see for a second, 18 years, 11 days, and 8 hours. and then we'll do it again for a third time. Okay, so that brings us around to 54 years and 34 days. Okay, once you have those 3 sequences, you basically have the pattern of all the eclipses that are going to occur. Okay, so you might have trouble with the solar eclipses. What you've got is the time when a solar eclipse might occur. So you have the danger of a solar eclipse occurring. But you will have the pattern of all your lunar eclipses. So you should be able to be pretty spot on with knowing when a lunar eclipse and what kind of lunar eclipse is going to occur as well. Okay, so and that is how lunar eclipses were worked out. And it was known for so long. If you've ever heard of the Antikythera device, I think some people will know about it. It was a device that was pulled up from a shipwreck. It was a bronze device. It had cogs and wheels in it. It was left to rot a bit, but it's been well studied with X-rays. And that was from Rhodia, from the island of Rhodes. And I've said the wrong thing here, but Andrew, you shook my head. It was from the island of Rhodes anyway. And that had perfectly made cogs in it that were perfectly made to predict lunar eclipses by the ancient Greeks. The sequence for lunar eclipses has been well known for thousands of years. Okay, so solar eclipses a little bit more difficult. Lunar eclipses pretty easy to do. Just got to count on your fingers. Keep really good records. So you find that all the civilizations that had written records knew how to predict lunar eclipses because they just kept really good records and they saw the pattern, and so they knew how to repeat it into the future. And that's basically how it was done.
There you go.
Oh, better step down now. Yes, stop taking it.
Thank you, Jackie. That was really informative. I'm going to now ask Stuart to come in to us answer a question, because we have Sophia, who is curious as to why the moon didn't turn red. Hi, Stuart.
Oh, there you You can speak, Stuart.
All right. I think that's unmuted. Sorry, my computer was having a bit of a fit there. Sorry, could you repeat the question again?
Oh, why?
Certainly. Sophia wants to know. Sophia is 5 years old, and she would like to know, and she is curious as to why the moon didn't turn red.
Yes, yeah, I can just briefly go over the. So the reason that the moon will be turning red is because of the light that's hitting it. So usually when we see the moon, it's illuminated by the sun with nothing in the way. So it's just a brilliant white light. Roughly the same color as the sun. But when it passes behind the Earth, it's no longer directly getting hit by the sun's light, but some light can go through the Earth's atmosphere and refract around it, and hit the Earth and hit the moon behind the Earth, and the light that travels through the atmosphere of the Earth becomes more red. This is the exact same effect which makes a sunrise and a sunset so extravagant in colors. It's the atmosphere takes away kind of blue from the sun's spectrum, and it spreads that blue color around the sky. That's why the sky is blue, and the remaining light that doesn't get bounced around by the atmosphere is red. And so the red is what's left after light travels through the Earth's atmosphere, and then the atmosphere also focuses that light behind it. So we'll only see the moon turn red when it's totally in the shadow of the Earth, so that the bright light directly from the sun doesn't drown out all the light that we can see. And it also needs to be in the middle of the shadow where the Earth focuses all this red light. A rather romantic way I've heard it put is that when you see a blood moon, you're seeing the light from all the sunrises and sunsets on Earth simultaneously. So I thought that was a very nice way to put it.
Fabulous. Thank you. Okay. Thank you for answering those questions. Andrew, did you want to say something?
Well, it's interesting that while Stuart was answering that question, of course, we had an image from, I think, from Pavel, where the moon is starting to look red. So there you go. It's now getting dark enough for us to see that colour. Not up in MBO yet, though.
No, not as of yet, but it is marvelous, yes. So up next now, we are going to have Jackie, and she will be talking and showing us about the background sky tonight.
Hello everyone. If the sky is clear enough where you are, the eclipsed moon will help you find a well-known constellation in the sky. To the right of the moon is a bright orange star that you might mistake for a planet. It is Antares, a red giant star whose name means the rival of Mars. It marks the heart of the Scorpius, who's one of the constellations of the zodiac. The moon will be under the head of Scorpius, and the long curving back of the Scorpion runs down through Antares, following a curve of stars into the Milky Way. That's this fuzzy looking stuff running down this part of the picture. Then the Scorpion's tail makes a sharp turn, bending back on itself as we see it in the sky here from Australia. The complete tail looks much like a fishhook to us, and you might think it looks like it's hooked into the Milky Way and pulling the Milky Way along behind it. The bright star here at the end of the tail is called Shawla, which means the sting. While the moon is darkened in the Earth's shadow, you may also be able to find the zodiac constellation that comes before Scorpius, Libra, the balance scales. There is a large triangle that marks the top of the scales, or the balance beam, up here. And these two funny looking legs that hang down mark the pans, and where the weights and the articles to be measured would sit. Libra's a little bit fainter, and that's because it's a younger constellation than Scorpius, and these parts of the constellation once made up the Scorpion's claws. So if you get a chance and a break in the sky, do go and have a look for the Scorpion. He's one of the few constellations that actually looks like what he's meant to look like up there in the sky. And you have all winter to enjoy him with the Milky Way.
Fabulous. Thank you, Jackie. That was really interesting. Okay, don't forget to keep your questions coming in and your pictures or your drawings. If you have some littlies at home that like to draw the moon, that would be awesome to see them too. So that being said, we are now having Adam hopefully popping up some pictures that have come through to us to show everybody the amazing photos that they've been taking. They were beautiful pictures. Thank you so much for sending them in. Don't forget to keep sending them in to lunar.eclipse@mbo.org.au. And also, if you're in Russia, we would love to see any pictures that you draw or any questions that you have to ask as well. We can't forget our friends in Russia. Now, we are going to have Andrew come in to show us again on Redshift what the lunar eclipse is looking like.
Okay, thanks again, Petra. This is how it looks virtually again, but you saw from some of the live pictures before that the moon is now much, much darker. There's only a small part that's lit up. So what I thought is I'll take you back to the moon. Let's go there. And we'll again look back towards the Earth and the Sun to see how things have changed. Since we last went virtually to the moon, we've now moved a little bit further around. And we'll just let it settle. Okay, so you can see that much more of the Earth's shadow is coming across now. So let's turn around so we can see back towards, there we are. Now there's the Sun and the Earth. Now, okay, from this side of the moon, right, the brighter side, we can see that there's some of the Sun's gone, so the light level will have dropped, but there's still a fair bit of the Sun lighting up this side of the moon, which of course is on the other side as we look at it. But let's go to the other side of the moon. And there we can see the Earth is now almost completely hiding the Sun. So only a very small amount of sunlight is getting through to that side of the moon. So again, let's virtually go around that side again. There we can see what I'm talking about. This side of the moon is darker and darker, but this side is still almost as bright as it normally would be. We'll quickly go back to Earth and have another look back again. And then ideally, if we could get a look at a live picture of the moon again. This is just how it is virtually. Okay, zoom in. We're seeing that the right-hand side is darker and the left-hand side is still reasonably bright. What you'll see in the MBO images has been brought through a telescope, and I believe that telescope inverts the image, so you'll see the dark on the left and the light on the right. But just in your mind's eye, swap them around, and that's how it actually looks. Of course, those of you who've been out, you can see what the moon's looking like now, and this is a good time for you to have another look. Just a small part of the moon will be bright. It's not like this computerized picture. It's much clearer in the Melbourne sky that this side is still reasonably bright, but this side is quite dark. You can hardly see it at all. Okay, so we'll go back to Petra again, if you're there. Hopefully Adam's had a chance for a little bit of a rest, but he might now put up, there it is. There's the picture of from MBO, is it? Is that one from Oriarum?
This one I do believe, I think, is from possibly from Mount Burnett. There you go. It's from Mount Burnett. Thanks, Adam. Thanks for letting us know.
No worries. That's the reverse, as I said, because it's through a telescope. Okay.
Fabulous. You. Thank you, Andrew. That answers someone's question, actually, who asks why we see it differently outside to on the screen.
Permission to go outside and have a quick look myself?
Yes, please do. I can't wait to go outside to see it myself too, because I have clear skies as well.
Beauty. Thank you.
Thank you, Andrew. Yes, and if you haven't popped outside as of yet, please do. We would love you to go outside. We are including you in this stream. You, the public, are part of this, because we would love for you to send your photos or your drawings to lunar.eclipse@mbo.org.au. And as you can see, Adam is now bringing up some more pictures that people have sent in to us. Thank you, Adam. Okay, we're going to answer maybe one or two more questions before we can maybe get around to showing some more pictures or drawings. So don't forget to send them in. And a lot of you are asking, it's lunar.eclipse@mbo.org.au. Okay, so up next, I'm going to invite Stuart into the stream, and his question. Hello, Stuart, and your question. The question has been asked by Dylan. Dylan has asked, how high can you jump on the moon?
So yeah, that's a fairly simple one. The gravity on the surface of the moon is roughly six times weaker than on Earth. So you will weigh 6 times less. Everything will weigh 6 times less. You can lift a lot on the moon, and so you'll roughly be able to jump 6 times higher, in my professional opinion of the physiology of jumping. Of course, we probably wouldn't be used to moving around on the moon, so I don't know if we'll reach quite that high. Yeah, because we'd be stumbling around everywhere, but I'm sure it'd be quite fun if we had the appropriate spacesuit on. Yeah, so however high you can jump here, times it by 6.
Fabulous. Thank you for informing us about that, Stuart. I do have one more question before you shoot away. It's from Rachel, and they have asked, does the moon have rocks orbiting it?
Yeah, so the quick answer would probably be no, none that I know of or worth mentioning likely. Anyone else that's around, feel free to correct me if I just don't know about it, but I don't know of anything that no natural body that really orbits the moon. I think there might be a few satellites that orbit the moon, but I don't know them off the top of my head. I was just trying to find a list before, but couldn't really find anything. But I assume, yeah, there are a few satellites that orbit the moon. But one thing that makes it difficult for things to orbit the moon is the gravity around the moon is very lumpy. There are some regions of the moon, if you're orbiting around the moon, there are some regions that have extremely strong gravitational fields, relatively, and there are other regions where the gravitational field is weaker. So you get attracted more towards the moon here. You kind of float away over there. It's very uneven, and that actually makes it very hard to find a stable orbit. If you have an object near the moon, it won't be traveling in a perfect circle or a nice looking orbit. And in that way, it's actually very hard for objects to orbit the moon compared to other celestial bodies, because they'll be pulled into the surface or just float away. We have found some semi-stable orbits by using giant computers to simulate these really complicated, kind of really wobbly orbits that our satellites can fly through with minimal correction. But by and large, there aren't many stable orbits that you can have around the moon without manually correcting like human spaceships can.
Fabulous for that. Thank you, Stu. Okay, we will now go to a news break.
On May 5th, marking the 60th anniversary of the first American flight to space, SpaceX has launched and successfully landed its incredible Starship after 4 failed attempts. The successful test flight of the SN-15 prototype is a major step in the program that Elon Musk intends to use to land astronauts on the moon and send people to Mars. This latest upgraded version of SpaceX's full-scale prototype soared to 10 kilometers and hovered over the Gulf of Mexico before executing the flip maneuver and descending horizontally. It then returned to a vertical position just in time for touchdown in less than 6 minutes. After the success, Elon Musk stated he would like to refly SN-15 soon, an achievement that would see SN-15 become the first reusable Starship. As a result, SpaceX's Boca Chica facility has kicked into full gear, with SpaceX's Super Heavy platform being prepared. Booster BN3 is likely to be paired with SN20 as the company aims to perform Starship's first orbital flight later this year.
Thanks for that news, Adam. That's really interesting about SpaceX. Okay, as you can see, we have a view from Pavel's telescope, which is live in Ashwood. Please remember to keep sending in your photos and your pictures to us. I can see on my end that our email boxes are getting full. Okay, so it shouldn't be too long now till we will see the total lunar eclipse. I suggest you go outside again, take some photos, draw some pictures. We're just going to take a short little break and have the moon on the screen for you, but we'll be back shortly. Okay, for our viewers, just letting you know that the totality of the lunar eclipse will begin shortly at 9:11. I suggest that you go outside and watch it. Take your photos, or if you have binoculars, take your binoculars to have a good look. It'll probably run for about 15 to 20 minutes from start to end. If you have any questions during that, you can pop them into the comments and we'll attempt to answer them when we come back. But again, MBO personality here will be taking a break to also be able to go outside and enjoy this total lunar eclipse. There will be silence as we can't run any music. We would love to run you some music, but we can't, unfortunately. So you'll have to enjoy our beautiful lunar eclipse in silence, or even better, outside. We'll see you back soon. Okay, welcome back. Some of you may still be outside, but some of you may still be with us. I hope you enjoyed that total lunar eclipse. I know I did. I actually had a break and I went outside to have a look as well. It was just beautiful. Okay, next up, I'm going to bring Andrew back in and he's going to show you what the eclipse now looks like on Redshift.
Again, folks, wasn't that absolutely awesome? Fabulous. All right, we're back out behind the moon again and looking back towards the Earth, and you can now see the sun is totally covered by the disk of the Earth. If we go to the other side of the moon, there it is, and this is current, but strictly speaking, we're probably just coming out of the total shadow. So any second now, hang on, what's that? 9:28. Yeah, that's about when it finished. So the moon was totally within the Earth's shadow. Oh, there's the sun just might be appearing there. So now this side of the moon will start. Hang on, let's turn it around and go back to normal time. Now you're seeing that one side of the moon will now start to get brighter as the sun reappears around the edge of the Earth. So you'll see the opposite of what you've seen for the last 2 hours. Those of you who need to go off to bed, yep, you've seen it all just in your mind's eye. Run it all backwards and you'll see what's happening for the next 2 hours. So thank you very much for that. But there we are. The Earth is totally covering the disk of the sun. Okay, back to you, Petra. Okay, and of course we welcome any further questions that you have.
Thank you, Andrew. I really do love Redshift. It is amazing. Okay, I am now going to ask Jamie to come on in and she's going to answer a couple of questions. The first one, hello, Jamie. The first
Hi,
one.
Petra. How are you?
I'm good, thank you. How are you?
I'm great, thanks, Petra. Just saw totality outside my front door. Absolutely amazing. Nice and red from outside my house, which is wonderful.
Yes, it was beautiful. I went outside and had a look too. It was just amazing. Okay, so your question tonight, Jamie, is Debbie has written, my son wants to know if the lunar eclipse will be visible for all countries when it's their Wednesday night, or is it just in the southern hemisphere?
So with that one, unfortunately, it's only for a select area of the Earth. So it depends on where the shadow falls on the Earth as to where we can see the eclipse from. I haven't been watching all of it. I think Jackie may have mentioned this at some point or someone else did. But there is only a small shadow in relation to the whole size of all of Earth. So there's only certain areas that you'll be able to see it from, and there's an even smaller area where we can see it at totality like what we see tonight. So we're very fortunate that we're in the right spot today, but unfortunately, no, it's not one of those things that it happens everywhere when it gets to that time.
Fabulous, thank you. And I have one more question before we go to a news break. Riley, who is 10, would like to know why you can only see the Scorpion star constellation in winter.
Great question, Riley. So that depends on where the Earth is in relation to all the stars around us in the galaxies. So when we're in our orbit around the sun, we go, so we've got the sun here and we go in the Earth, we go around like this. So we're on this side. So say we're on this side in the summer. Okay, this is when we can see Orion the Hunter. All right, so you can see a different group of stars all the way out here. But if we go all the way around the sun, those stars disappear behind the sun here. We can't see past the light coming off the sun. So then what happens is we can see all the stars on this side of Earth. So this is the sun, the Earth is about here, and we've got all these other stars off to that side there. Those stars aren't blocked by the sun's light, so we can see those ones, but we can't see the ones on the other side because the sun's in the way.
Fabulous. Thank you for that information, Jamie. Okay, viewers, now for our news break. Okay, well, we had a little bit of technical difficulties then. So, Adam, we'll need to run that news break again as we could not hear you. Could you please
No
do that
problem.
again? Sorry. As always, we always have technical difficulties, and that's okay. Thank
That's
you,
showbiz.
Adam. It is showbiz.
Astronaut Kayla Barron has been assigned to NASA's SpaceX Crew 3 mission to the International Space Station, expected to launch October 23rd. She'll join NASA's Tom Marshburn and Roger Shari and European Space Agency astronaut Matthias Maurer. This is SpaceX's third crew rotation mission to the space station. On May 20th, engineers at NASA's Langley Research Center wrapped up the latest series of water impact drop tests for NASA's Orion spacecraft. The test series was designed to provide a better understanding of what Orion and its crew may experience during splashdown water landings at the end of future Artemis moon missions. Data from the tests are also used to help verify that Orion fulfills structural design requirements ahead of Artemis 2, which will be NASA's first Artemis mission to the moon with astronauts on board. Also on May 20th, engineers at NASA's Stennis Space Center conducted an RS-25 engine test, continuing the latest test series in support of development and production of these engines. 4 RS-25 engines will power NASA's SLS rocket system during future Artemis missions, including flights that will land the first woman and person of color on the moon.
Thank you for that, Adam. That was really interesting information. Okay, so I'm going to bring in now Jamie again and Stuart to answer some questions. Okay, welcome again. So this first question is for you, Jamie, and it comes from Karen, and she has asked, why does the moon turn red? Why not blue?
So that one I'm going to answer as simply as I can. So that has to do with Earth's atmosphere. So there's a lot of dust and stuff in the Earth's atmosphere, a lot of pollution, smog, all that kind of stuff. And that affects the light coming through the Earth's atmosphere and hitting the moon. So the sun's light passes past Earth and goes through and hits the moon. And the dust and stuff in the Earth's atmosphere distorts the color of that light. And so it appears red to us when it's reflecting off the moon in a lunar eclipse like this.
Fabulous. Thank you for that information, Jamie. Now, Stuart, your question is, and I'm curious about this question too. Kelly asks, can a lunar eclipse ever occur in conjunction with an aurora, or has it ever happened both at the same time?
As always, I'm ignorant to the more history side of things, so I don't know off the top of my head if it's ever occurred. But I don't see any reason why it can't. It probably has, because both of these are, the root cause of both of these things are independent from each other. So the eclipse occurs because the moon is in a specific place with relationship to the Earth and the sun. A aurora happens because charged particles from the sun travel to Earth and get caught up in its magnetic field and get funneled down into the atmosphere at the North and South poles. So there's no reason why you can't have high solar activity as well as having the moon in a specific place. And I really wouldn't be surprised if it's happened because, both events are fairly common. The lunar eclipse goes for however long this stream goes for, after so many billions of years, it's bound to have happened at some point. Though you will have to be at one of the poles or near enough to the Earth to observe the aurora. You can't be anywhere on Earth to observe the aurora, so you'll have to be at one of the poles to see that portion of the event.
Fabulous. Thank you, Stu. And I have one more question for you before we go to the public's pictures and photos again. Andanen, and my apologies if I didn't pronounce your name right. How was the moon formed?
Yeah, that's the big question, isn't it? I believe there's some controversy, and there's always going to be a bit of a discussion. It's still a very active area of research for scientists. But the most common theory that we have, well, the most well supported that we have at the moment, is this giant impact hypothesis, where a large object the size of Mars, I think they call it Theia, it crashed into the Earth in the very early stages, in the first billion years or so after, and smashed into the Earth, and along with turning the surface of Earth into a molten magma, it would have smashed off a large chunks of the Earth, and most of this crashing body, Theia, would have like split into lots of different rocks and started orbiting around the Earth. And so for a bit of time, the Earth had a beautiful planetary ring. And eventually all of those clumps of rock would slowly smash into each other and clump together under the pull of gravity, and we end up with the moon orbiting around the Earth. So that's the current theory. It has its pros and cons, but yeah, it's certainly an exciting theory.
Fabulous. Thank you, Stu. Okay, we are now going to show some of the photos and pictures that you, the public, have sent in to us.
All right. Well, this one is a drawing from Arav in Brisbane. This one is rather nice, actually. You can see the red coming in over the side there. Very impressive. Stuart, what do you think on this one?
Yep, no, very good. Very good diagram.
Yeah, it's a good way to explain what happens during an eclipse, though, isn't it? How the red comes over, but it's more of a progression, so it's not, the whole thing's not coloured in, which is really good to see. Nice attention to detail.
Scientific accuracy.
Yeah, yep, 100%. Oh, this one's nice. This one's from Alia in South Australia. A nice detail there as well. Stuart, what do you reckon?
Yeah, no, it looks lovely. Definitely better than anything I could definitely take. Don't have any experience myself.
I tried taking a few on my phone during totality and not that good. So you're doing better than me, Alia. Great job.
Yeah, well done. Oh, wow.
Oh, there we go.
That's
nice.
really good.
Yeah, nice red color on that as well. Great exposure.
Yeah, you can definitely
Good
pick it
job.
out.
Yeah. Coming into totality there, which is great.
Yeah, there's something good about having it like at the partial stage of the eclipse too, because then you can really tell it's just an eclipse and not just a dim picture of the moon. There's something exciting going on here.
Yeah, no, images can be deceptive like this. This one is from Braden. Awesome to see that you want to be a meteorologist there, Braden. Great job, great career to have. All right. Oh, nice red one from Heather. Great job, totality there. Beautiful, beautiful photo there.
Yeah, and you
zoom
can
in
really
a
see the
little bit.
detail on the surface, doesn't it?
Yeah, nice lava craters there as well. Loving these. Some amazing pictures coming in. Oh, here we go. Another drawing from Layla. Apologies if I pronounced your name wrong. Nice attention to detail with the craters on there as well. And you've only got part of it showing up. Awesome job. Oh, great job, guys. That looks awesome. Love the clouds coming over that too. Yeah, get a little bit zoomed in on that. That's it. There we go. Beautiful.
Great to see you all so excited.
Oh, there we go. You see a little bit of redness in that one there. Yeah, nice photos, guys. Keep them coming in.
Oh, we've got someone who traveled to the moon.
Are you standing on the moon there, Sophia? Are you standing on the moon?
Yeah. And you know, we might be going back to the moon fairly soon. There's
Oh,
talks
that'd
of
be pretty
plans
cool. Yeah. Love the
next few years.
stars in the background too. Yeah.
They were some pretty cool pictures and drawings, weren't they, guys?
Oh,
Yep.
absolutely. Keep them coming in, guys. Keep taking photos, keep drawing pictures, keep
Yes.
sending them into us. We'd love to see them.
Please do, because don't forget we have 3 planispheres to give away tonight. 1 for the question of the night, 1 for the photo of the night, and 1 for the drawing of the night. And don't forget, the winners will be posted on the MBO page, along with some other notable pictures and drawings. Fantastic. Okay, so we're just going to allow you to pop outside again to have a look at the moon, and we will be back with you shortly. Okay, we are back. Now it is starting to get a bit late, and I know some families would like to put their young ones to bed, as it is a school night, as Jackie said earlier on. So we are going to announce the winners. With that being said, please keep sending through all your pictures, wall drawings and photos, and still please ask questions even though we've announced the winners of the night, as we will continue to answer them throughout the evening until the end and show them as well. So we've decided that our 3 winners tonight are, for the drawing, it is from Sia, who sent in the first drawing of the evening. Our photo of the night is from Braden. And our question of the night, which hasn't been answered yet, so I'm going to get Jackie in to answer this question because it is a really good question.
Hello.
Hello, Jackie.
Yes. And the question is?
It's about the eclipses with being in a demos. I can't even pronounce it.
Demos and Phobos.
Yes, you know
that's
this
right.
question.
Yes, I was reading it about eclipses.
Yes.
Have they been captured by the rovers on Mars?
Yes, and this question
yes, they have. Yeah. Oh, yes, it's by Olivia, wasn't it? Sorry.
Yes, that's okay. This Olivia, that's all right. This question is by Olivia, and she is 10 years old. So I was like, wow. And her question was, have any lunar, Phobos, or Demios eclipses been captured by rovers on Mars?
Yeah, so Phobos and Deimos are the 2 moons of Mars, and they mean their names mean fear and terror. So they're the 2 horses that the god of war had on his chariot. So yes, they're little lumpy moons. They're chunky bits of Mars, and they don't actually cover the sun, but yes, the rovers in the past, I think it's probably Spirit and Opportunity, the 2 that are no longer operational, they have caught little a series of photos of those moons passing in front of the sun. But they're too small to cover the sun up. So in a way, they're not really eclipses. They're probably what we would call transits, because the moons were transiting across the sun rather than eclipsing the sun. So yes, we have seen that happen from other planets. But we do get to see other eclipses happen, and that's with the moons around Jupiter, because they are big enough to eclipse one another. And we get to see that over the space of 12 months every 6 years, because Jupiter takes 12 years to go around the sun. So every 6 years, it reaches its equinox, and we get to see the moons of Jupiter sort of going edge on around its equator. And the 4 big moons, the Galilean satellites, do you remember their names? Io, Europa, Ganymede, and Callisto. They will go through a sequence over around 12 months of eclipsing and transiting each other and doing all that, a full sequence of that. And there are people that go out and take recordings of those and watch the light dim and come back to brightness. Some of it happens slowly over a couple of hours. Some of it's short, over about 20 minutes or so. So observations are made of them, and that's actually happening this year. That's one of those 1 in 6 years that it's happening. So there's not too many of them this time around, but yeah, this is one of the times it's happening. So yes, we do get to see eclipses from other planets and eclipses happening around other planets. We're just actually in a really, really lucky situation where the moon's in sort of just the right place and it just covers the sun. It's a really amazing coincidence. But yes, and yes. So there you go. The answer is yes. eclipses or transits have been observed from Mars by the rovers. There you go.
Fantastic. That is so interesting and so cool to know. And someone did say in our comments that it is a really cool question, because it is. So what I would like our winners to do is to make sure they contact us either on our Facebook Messenger or on our email, which is at prizes@mbo.org.au, so we can, with your details, so we can send out those planispheres to you as soon as possible. And thank you, Adam. Adam's popped that email on the bottom of the screen. If you didn't get it, it's prizes@mbo.org.au. Okay, so now we're going to have another news break.
Virgin Galactic completed its third space flight and first ever launch from Spaceport America, New Mexico. The flight on May 22nd sees New Mexico become the third US state to launch humans into space. Virgin Galactic fulfilled a number of test objectives during the flight. Spaceship Unity carried scientific research experiments as part of NASA's Flight Opportunities program. The team collected data to be used for Virgin's final 2 test flights, a critical requirement for reusable spacecraft. And this flight also allowed the team to check the spaceship's upgraded horizontal stabilizers and flight controls. Spaceship Unity achieved a speed of 3,700 kilometers an hour, or Mach 3, after being released from mothership VMS Eve, and reached space at an altitude of 89 kilometers before gliding smoothly to a runway landing at Spaceport America. It's an exciting time for Virgin Galactic, who have even hinted the program could evolve to point-to-point travel, with flights taking passengers from Sydney to London in as little as 2 hours.
Thank you for that news, Adam. Now, I would like to invite in Drew and also Stuart to answer a couple more questions. So the first one is from Stefan, or Stephen. My apologies if I pronounced it incorrect. And this one's for you, Drew. And the question is, will the moon collide with the Earth one day?
Yep, thanks for that question. The short answer is no. The slightly longer answer is it was actually closer than it was, and it's moving away very, very slowly. Now, Jackie mentioned a short time ago that the fact the moon can completely cover the sun and that they appear the same size in the sky is an amazing coincidence, and one we really need to treasure now, because the moon is moving away, and it's only moving at about 4 centimeters a year, I believe. So it's very, very tiny considering how big the Earth and the moon are, but it's very, very slowly moving away from us. So no, it's not going to hit us. It's going to keep separating from us. A long way in the future, it'll be so far away that we only get annular eclipses, because it won't be big enough in the sky to cover the sun, because it'll be too far away from us for that. It's not going to fly off into space. It's not going to cause great catastrophic effects, but it is moving away bit by bit by bit. So again, treasure these eclipses. Now we're in a really fortunate time of history where the moon is at the distance it is in the sky from us.
Could I add a fun fact onto that?
Go for it.
Yeah, the reason that the moon is going away is because it's being pulled by the tides of the Earth, and it's kind of stealing the spin of the Earth. So while the moon starts to spin faster and travel away from the Earth slowly, the Earth will start to slow down. So the escape of the moon, the moon traveling away from the Earth, correlates to the days of the Earth becoming longer. So every so often we have to add a leap second onto our atomic clocks that are calculating the day and whatnot. That's because the Earth is stealing our angular momentum and making our days longer.
Fabulous. Thank you for that. Now, this question is for you, Stuart, and it's from Fraser, who is 8 years old. And they are asking, why is the moon circular?
Yeah, so the moon is a sphere in shape, and you'll notice that many things in space appear as spheres, like the Earth, the Sun, all the planets. This is because of gravity. So when a bunch of stuff falls together, it likes to form a sphere because gravity pulls everything together. And if you imagine a really, really tall mountain or something on the Earth that's reaching towards the moon or something, then you can imagine like a small push one way or the other, or a small earthquake or something, and that whole giant pile of rubble is just going to fall over. So things want to be close together, and the shape that allows everything to be as close as it can be together is a sphere. So when objects have a lot of gravity, like astronomical bodies like the moon and Earth, they like to form spheres, and that's why we see them as a circle in the sky.
Fabulous. Thank you for your answers, gentlemen. I am now going to ask Jamie to come in, as she is going to show, hi Jamie, show some of the public's images or drawings for you to view.
All right, so we're back for some more image reviews. All right, here we go. First image up. Here we go. Oh, nice photo there. Good shot, and Andre. Apologies for my pronunciation once again. It's got some nice detail there. We can see the lava craters in there as well. Really, really nice. Great shot. Oh, we've got another one here. This one's nice and red. This one must have been taken during the totality phase of the eclipse. That's an amazing shot. Right, next up from Jessica. Oh, again, beautiful red shot. That's absolutely amazing. You got a few stars in the background there as well. That's incredible. Great shot, Jessica. Really, really nice. All right, Phil and Catherine, nice drawing. The moon from my point of view in Adelaide. Oh, a bit cloudy there, I'm guessing. That's unfortunate. Well, at least you were able to see it on the live stream here with us. So great job. Oh, got another drawing here. Who's this one from? I can't see a name there. That's okay. This one is from, oh, it must be from Phil and Catherine's kids again. This one's nice as well, during totality there as well, or the umbral phase. Must be turning red there. Oh, Piper, great job. Got the craters in there as well. Nice red color. Love the excitement on your face there as well. Great drawing, Piper. Love it. Great stuff, guys. Keep them coming.
Yes, they were amazing. I'm just absolutely loving these photos and pictures that everyone's sending in. It's just been an amazing job by you all, the public. Okay, so we are going to actually, Jamie, don't go away just yet on me. Come back in, please. I'm going to get a question out to you. And this one is from Ava, who was 9 years old. And she has asked, there's a couple of questions in here. She's asked, why does the moon get so many asteroids? And does the Earth or moon have more craters? I think she wants to know which one has more craters.
Okay, well, that is an absolutely awesome question, Ava. Really glad you asked. So the moon has more craters on it, and that's kind of because it acts almost like a shield for the Earth. So what happens is that the asteroids come in, so they come out from usually beyond the orbit of Mars, which is further out from the sun than what we are. So they come in and they're going to hit the Earth. They're going to smash into it and make lots of explosions and things. Kind of, being colloquial in my language there, so just being very casual. But what would happen if Earth was hit by an asteroid is, depending on how big it was, something similar to what happened with the dinosaurs when the dinosaurs died. Again, depends on how big it is. But the moon being where it is, protects Earth from being hit by a lot of these asteroids. So we can thank the moon for being where we are today. So thank you, moon.
Yes, indeed. Thank you, Moon. Okay, so we've got I think we're going to show some pictures to our public about what we have set up at MBO tonight so they can have an idea of the work that's gone into tonight's live stream. So, Adam, how are we going with that? Are you able to? No, he's going to show us Pavel's live. No. We're bringing up, oh, here we go. Yep, he's bringing it in. There we go. Now I'd like to call Andrew in. Andrew, can you come into this? Thank you, into the stream with me. A lot of this information, as many of you probably don't know, I know a little bit about telescopes, but not a lot. I'm not the experts in them. So a lot of this language is a little bit foreign to me, as it may be to some other viewers. Are you able just to give a little bit of a brief rundown of what this is?
Looks a bit like a refracting scope. In other words, one that uses lenses rather than mirrors. And it's fitted to an equatorial mount. I don't know whether you can, yes, you can see something at an angle and then another one at 90 degrees to that. That angle is about 38 degrees because that's Melbourne's latitude. So that means that it's parallel to the Earth's axis. So a motor drive in the next portion, just below the telescope, will then turn the telescope at the same rate as the moon is moving across the sky. So we keep that image in the middle of the scope. That's telescope itself. The rest of it, we need Neil tonight, don't we?
Yes, no, I think Jackie's coming in. Jackie might be able to help us. No, yes, no.
I can add a couple more things.
I'm just wondering, can we see where the camera is? Because most people want to know where the camera is attached to. Are we able just to zoom into? There we go. Thank you so much, Adam, for that. Because most people wonder, where do you pop the camera on a telescope? I know I have. So there we go. We can see that camera, and the camera is a ZWAS, as you can see on the screen, ASI 183 MC Pro camera attached. Okay. So and aperture. Someone spoke about aperture the other night. I think it was Stuart that talked about aperture. Maybe Stuart can come in and fill us in a little bit on the 123 millimeter aperture. What does that mean, Stuart?
Yeah, I'm not an expert on telescopes here. You probably, Andrew, Jackie probably know more than I do, but
that'll be the primary lens. Yeah, it'll be the primary lens.
The aperture is how wide the primary lens is. So at the top left, the diameter, that's how it's usually quoted. The diameter of the hole that it allows light to travel through is the aperture. And in general, that allows you to see dimmer things because you can collect more light with a larger hole that lets light in. You can just think of a telescope as a giant light bucket, and the aperture controls how much light you get.
Yes.
Fabulous. Thank you. That does explain a lot. Thank you so much for that. Okay. All right. So, Andrew, would you like to say something?
Just wondering whether Anthony's up there. He set it all up.
Anthony is our guy to speak to. We might see if we can contact him and see if he's willing to come in and have a little chat about it. If not, we'll just take you, the public, to a view of our MBO, what that actual telescope is showing you on the screen tonight, so you get an idea. Thank you, Adam. Okay, we have collated some more photos and pictures to show. I'm just waiting on Adam to bring them in for us to have a look. Then we will be... Oh, hello, Andrew. Andrew, you're coming in. Are you going to show us something, Andrew, on Redshift maybe? No?
I had something on before showing that a moon passing in front of Jupiter, but at the moment we've just got a virtual view of what it would be like looking at the moon now, because there's a lot of cloud coming in, so that's there if we...
There is unfortunately some cloud coming in. We are experiencing those difficulties through our telescopes as well. And unfortunately, so be it, we don't have control over the weather. So we will be showing some pictures, and then viewers, we will show a little bit of the moon because we want to get it on as much as we can before we lose it completely behind the clouds. And then we will cross to our friends in Russia again, as they would like to have a little chat with us again as well. All right, so here we go. We have, this is from Rachel.
Yes,
that is great.
It looks like an attempt to photograph the moon through a telescope, because we've got the edge of it sort of showing there, and we've got the colour showing. That's really impressive that they've got the colour as well, and the patience to get an image probably on the phone through a telescope. Very well done. Yes.
Yeah, excellent. Oh wow, look at that one. That's from Rebecca. Rebecca, that is amazing.
Oh, where is Rebecca? Because that's very low, isn't it?
It is very low, but it is early on, but it's still really beautiful. Look how brown that is and beautiful it is. Yes, Amber, it is so beautiful indeed. It is fabulous. Is this is from, I'm presuming, Rosanna, and it's from a Saxon telescope, possibly.
Yes, again, very well done, because it won't have an attachment for a camera, so a lot of patience and skill required to hold the camera steady and get that sort of a shot. Very well done. Clearly the moon crossing, the shadow of the Earth crossing the moon there.
Indeed, you can see it really, really prominent there. That is amazing. Thank you, Roseanne.
Yes. Well done, Roseanne.
Okay, this one is from Tony. Tony, can you see the red in that? Yeah, thank you, Adam.
Yes,
look at that beautiful red moon. It's just gorgeous.
What's so impressive about this one too is how steady they've held the camera, because to get that sort of exposure, they've got to hold it very still. It takes a little bit of exposure time to get that. So very, very well done. Good colour, and just looks like they didn't have much zoom on. It was, again, probably a phone.
Yes, it does look like from a phone. Yeah, it is well done. Looks great. Thank you, Tony. That is beautiful. Oh, and this one is from Tracy. Look at that. That is lovely.
Full frame there. Very well done.
It is full frame, and you can see it's just really, I must say to all the public who are still viewing, I know some may have gone to bed as they have work tomorrow and for the little ones school, but you have done a fantastic job tonight, you the public, in sending in your pictures and drawings. Just amazing. Great job. Well done. We have another drawing. I'm so in love with all these drawings. I wish I could just give them all prizes, because I just think they're just fantastic. Victoria has done, look at that.
That's good.
What phase would that be, Andrew? Because you can see some of the red, so it's definitely coming out of its totality. So she's definitely stuck around to go outside and have a look afterwards.
And I think it would have been earlier tonight, before totality, because you've got the lit up bit on the right hand side. Is that right?
Yeah, I think she's doing the red. Is this
some time? And very nicely done.
The red is very nicely done, Victoria. Well done. Okay.
Found the right colour in the pencil case.
Yes, she certainly did. Good on you, Victoria. That is fabulous. Okay, that was our last image for this evening. And now we're going to take you back to the moon before we lose it behind those clouds. Thank you, Adam. Okay, we are back. As you can see, the moon is still beautiful from Pavel's view live in Ashwood. Okay, I would now like to bring into our stream Pavel from Russia. I'm going to bring hello Pavel, welcome again. And he's just briefly going to say a few words to all of you. Thank you, Pavel.
Thank you, Petra. It's an amazing experience for all of us.
Sorry, Pavel, you've just some technical difficulties there. You've just gone on mute. We just need you to unmute so we can hear you. Thank you.
Can you hear me, Petra? No?
Yes, we can hear you now loud and clear. Thank you, Pavel. Thank you.
Okay. Dear friends, it was really an amazing opportunity to have an experience with the Australian amateur astronomers, and which is much more important to show the lunar eclipse, so marvelous, so fabulous lunar eclipse from the southern hemisphere to the northern hemisphere, to the Russia. You know, we have our own chart, and we got a lot of messages from the far east part of Russia to the far west part of Russia, and everyone were watching this astronomical event, and are very surprised, are very surprised about our big universe around us. They got a lot of information about the celestial bodies, about the mechanic of the lunar and solar eclipses, about the opportunities that amateur astronomers grant to the public. And personally, I want to thank you, Petra, for organizing this experiment, to Pavel Mironov, to the person who who has this idea for a couple of years, and finally we got this idea into reality, to his presentation, his splendid, excellent presentation with bears and kangaroos who were looking at the same time at the moon and seeing the different scenes, the different skies at the same time. Maybe we will be able to look at the parallax, not only Moon but Mars parallax, during our other sessions. And also I would like to say thank you to every one of you, to Andrew for his viewing from the Redshift program, especially from the view behind the moon on this eclipse, and to Adam for technical support. I know for a couple of days our technical specialists were working hard with Adam in order to fulfill this idea into life. And once more, I'm glad to invite you to our eclipse. We will arrange this eclipse, and at 10th of June, we will have the partial solar eclipse in Irkutsk, and we will make a translation, not translation, a streaming of this eclipse to you, dear friends. And once more, thank you very much for an opportunity for Russian audience to see this event from our part of hemisphere. I would like to say the hope to make sometime another so interesting streaming from South Hemisphere. Any comments? Maybe you can say something back, different.
Fabulous. Thank you for that, Pavel. And we thank you for joining us as well. It's been an amazing experience having you on board. We do hope that later on, as the eclipse is coming to a complete end, that we could cross live over to Russia to see the moon rising. Hopefully we're able to...
I forgot to say that we're still waiting for the moon to rise in Irkutsk. And about within 20 minutes, I think within 20 more minutes, we will see the rise of the moon under the horizon in Irkutsk. Not earlier. Excuse me, we can't rotate the Earth,
No,
even we are in the northern hemisphere.
No.
But it's unprecedented stream, and thank you. We love you did this.
No, you helped us too, so you must take some credit as well.
Okay. Thank you.
Okay, thank you.
Thank you.
Thank you.
So please coordinate. We will write you when we will get the picture of rising moon in Irkutsk.
Yes, I look forward to it, to crossing live to Russia with you. It'll be absolutely amazing. Thank you. Okay, so we are now going to go to a news break. Stay tuned.
News break.
The 22nd SpaceX cargo resupply mission will carry scientific research and technology demonstrations to the International Space Station on June 3rd. Let's take a rare glimpse of what experiments will be arriving at the incredible research outpost in June. The Amami experiment will examine the effects of spaceflight on microbes and their animal hosts using glow-in-the-dark bobtail squid. Microbes play a significant role in the development of animal tissues and human health. Pilot is an investigation to test the use of robots and vehicles using virtual reality. These tests will provide valuable information to support future spaceflight. The cell science experiment utilises tardigrades, also known as water bears. Examining them in space simulates the stress on astronauts and may help develop countermeasures. Butterfly IQ ultrasound demonstrates portable ultrasound equipment. This technology can provide medical capabilities for future missions beyond Earth where support is not available. And finally, new solar panels are headed to ISS. The arrays will increase energy to support these research projects and other station activities. These are just a few examples of many projects on board helping to improve humanity and science.
Fabulous. Thank you for that news, Adam. That was very interesting. I'm really curious about those water bears. Okay, so viewers, we are just going to show you some of the moon again. Hopefully we can get, are we at Pavel's? Yes, we are at Pavel's. Fabulous. In Ashwood. His telescope's streaming to you now on the screen. We're going to just take another short little break, but we'll be back soon as we're just going to get ready to hopefully at the end of the eclipse, which is arriving shortly, to cross over to Russia to see the moon rise. Stay tuned. We shouldn't be too long. Thank you. Okay, I have a question coming up now for Jackie. Can I bring Jackie in, please? Thank you. Hello, Jackie. I have a final question for you before we say our goodbyes to you, and it was from Rebecca. And Rebecca has asked, what's Jackie's favorite constellation? I'm curious about this one too, Jackie.
Well, it's actually Cygnus the Swan. Has my favourite deep sky object in it, part of a supernova remnant that looks like a bit of a wispy veil. It's part of the Veil Nebula, and it's in the northern sky. It's quite low to the north from Melbourne, so you don't get to see it very often. It's around in the evening sky in springtime, and we actually get to see it upright. It looks like a big swan with its wings spread out wide, flying up the Milky Way. And a
Fantastic.
bright star called Deneb marking its tail.
Yeah, that's awesome. And it's really interesting that because we don't normally see things upright. We always see them upside down.
Yes, we get lots of people from Northern Hemisphere saying, oh, but Orion's upside down. Yeah, well, we see Leo upside down here, so it just depends. It's just a matter of perspective.
Of course.
Yeah.
Fabulous. Thank you so much. And thank you for your help and your presentations tonight, Jackie. You have been an amazing presenter as always. So I will say my good nights to you and stay tuned, everybody. I'm going to ask some more of our panelists what their favourite constellations are. Thank you, Jackie. Good night. Okay, we have been, Adam's been putting up some lovely messages from you all tonight. It is really wonderful to read them all. Okay, I'm going to now ask Stuart to come in because he is actually going to tell us about his favourite constellation as well. Hello, Stuart.
Hi, everyone. Yeah, I get everyone's favorite constellation. Yeah, lots of good constellations out there. My favorite, the one that comes to mind is probably Scorpius, which is probably topical tonight because it's the constellation that you'll find the moon in at the moment. So look up at the moon. You'll probably know where that is from straining your neck to look at it tonight. And right next to it is Scorpius. it's my favorite constellation because it actually looks like what it's supposed to. It has a distinct shape to it. You can see the body of the scorpion and the bunch of stars out the front, which could be the front of a scorpion. And most distinctively, you can see the curve of its tail as it comes around into a pincer. I think it's called the hook in was it Maori? Or yeah, traditions are in the yeah, but yeah, it's actually recognizable constellation instead of a dot of a scatter of stars that you can draw lines between.
Yes, it is. Jackie mentioned that too. It's in the background sky tonight. It looks really amazing, actually. And then the Libra is just above it, which was really interesting to learn as well. Okay, we have a question from Dot. And Dot asks, and this is for you, Stuart. Dot has asked, does the moon govern the tides or does the Earth pull do that? And that is a really good question.
Yeah. So yeah, it's yeah, a bit to get your head around tides. But yeah, so the main force of anything on the surface of Earth is the gravity from Earth. So that's the primary force that's holding everything down. So that's the primary thing that all the water feels. It's stuck to Earth. But it does experience a tidal force from the moon. Now, a tidal force comes from the fact that the force of gravity changes over distance. So the closer you are to the moon, the stronger gravity you experience attracted to it. So if you're on the same side of the Earth that's facing the moon, you are pulled more towards the moon than someone else. And if you're on the opposite side, you're pulled less. And so that kind of has a stretching effect because the Earth, it's helpful to think of Earth as kind of in free fall around the moon. That's what an orbit is. The moon is in free fall around the Earth, and the Earth is around free fall around the moon. So they just kind of hang there, and they don't really experience a force beyond that. And so on the near side, all the water is being drawn towards the moon, and on the far side of the Earth, the water isn't getting drawn towards the moon. So it kind of gets flung off a bit by the motion of the Earth, like going around a roundabout. You experience a centrifugal force. And so that kind of throws, so you end up with a bulge of water attracted towards the moon and a bulge of water away from the moon. So the tidal forces of the moon are what create the tides, because if you're in those areas where the water is drawn towards the moon or flung off by the Earth away from the moon, then you'll have a high tide. Though in practice, there's a lot more finer details because it matters about the local geography. It would be a perfect two-bulge system if there wasn't any land, but there's a lot of land on Earth. So water kind of sloshes around and hits some land, and so that's what causes a big variation in tidal effects that you can see across the world. So it's a bit more complicated, but the simple and picture is that the moon creates two main bulges that control the tides.
Okay, terrific. Thank you for that explanation, Stuart. Okay, so we've got some more public members' pics ready to come up for the pictures. All right, when you're ready, Adam, let's take a look at them. Okay, where's this one from Adam? Ariana, 8 in Queensland. Look how red that moon is, Stu.
Yeah, it's got a great color.
Thanks, Adam. He's going to take it as big as he can without it making it too distorted. That is just beautiful. Absolutely beautiful. So good. Fabulous. Thank you. And we have a drawing here. And who's the drawing from? Freya in Queensland as well. Do you think they're seeing, because we're seeing the red, is that coming up into totality or is that going away from totality? What do we think? Thanks, Adam.
Oh, it's got a happy star as well. Oh,
it has got a happy star. Look at the little smile on it. That is fabulous. Thank you, Freya. That is awesome. We have another one up there. Do we have another one for everyone to have a look at, Adam? Oh, wow. From Kim. That looks amazing. I always see a face in the moon. I don't know about you, Stuart. Do you see a face in the moon?
I always see a snail in the moon.
A snail. Okay, yep. I see a snail. I see a face.
It's going up the side of the picture now. It's
Yeah.
got the two antenna
yes, I can see that.
going
Yes.
to the right that way, and at the top, and it's going up the side. Got a bulge at the bottom. Yeah.
That is a beautiful picture, Kim. Thank you
Yeah,
so much. And this one is from Naga. And again, that looks amazing. It's just such a beautiful color, isn't it? It's just, I have to say it again, everybody. You have done an amazing job, you, the public, on your pictures and photos this evening. It's just been wonderful that you've taken part in this way. It's fabulous. Thank you. Okay, that was it. Thank you, Adam. They are wonderful pictures from everybody. Now, someone did ask in the questions where we get our t-shirts from because they want to get them. They are actually merchandise that we do sell on our MBO page. So if you would like to purchase any, please head over to our MBO page and take a look of what we have to offer. We also would love for you to like us on Facebook or hit that red subscribe button on YouTube. It is free. You don't have to pay any money. And we would also love, if you really, really want to, come and join us at MBO as members. We are always welcoming new members with open arms. Okay, so we'll just pop back to the moon now. And I'm just going to, because the eclipse is almost over, as we can see, it's coming to an almost end. I'm going to go and have a chat with our Pavel in Russia to see if they will be ready soon for us to cross live to see the moon rising. Stay tuned, won't be long. Okay, so our lunar eclipse is coming to an end. I am now going to invite Andrew in so he can show what Russia is now seeing over on the other side of the world before we cross live over to them for the closing of the show.
Okay, well, first here we are back at the moon, and you can see now that the Earth is sliding out of the way on that side of the moon, and on the other side it's still a little bit dark, but we're sliding out. So the sun is fully lighting up the moon almost. I'm just going to now fly back to the Earth, and we'll have a look and see what's lit up. And there's America's in day, Africa's in daylight. Now, if we have a look there, we can see that India has just had sunset, so they can see the moon now. And half of Russia, there we go, in the eastern part of Russia, they could definitely see the moon now, and they would have seen the partial eclipse, at least, not the full eclipse. And in the western part, the sun is just about to set. So the moon rise is happening to the east, the sun is setting in the west in central Russia. So I hope that's clear enough. And if there are any more questions, we'll answer them, but otherwise back to you again, Petra. And hopefully Pavel in Russia is ready to show us that moon rising.
Yes, thank you so much, Andrew, for showing us that. We are still just trying to work it out on our end. As you all know, when we're working with international, sometimes technical difficulties do arise, but we are, our team, my team, and Adam, my technical operations person, are working very hard behind the scenes to get this for everybody. So can you all please just stay tuned, and the show will close shortly, hopefully with the moon rising in Russia. Okay, hello everybody. Now it's time to conclude the show. I would like to thank again all my wonderful presenters for tonight and my technical operations person, Adam. They've done a fabulous job. Thank you for those of you that have stayed right till the end. I really appreciate it. I know it's been quite long and quite late, but now we are hoping to go live and witness the rising of the moon in Russia. And then there it is. There it is coming up. It's just beautiful. Absolutely
Is it
wonderful.
real?
Yes, we can see it. Hello, Pavel.
It's real. It's real. It's
It's
real.
real. Thank you. Can we bring everyone on? Yes, look at this. It is just gorgeous.
It's not under the horizon in all the full moon, but it's red not because it's on the shadow of the Earth. It's orange because it's very very low under the horizon, and you see it's moving.
Yes, we can. This is
Slowly,
live, everybody.
slowly
It's
moving.
slowly. This is live from Russia, everybody. This is amazing and it is beautiful. It is beautiful, Nessa. Indeed, it is.
Fantastic.
We are witnessing the moon rise.
Fantastic. It's a magic. It's a magic, dear friends. Yulia and Valery Shevtsovы made it from outskirts of Irkutsk. Yulia and Valery Shevtsovы made it.
We
Showed
must say
us
our thank
this
you to
moment.
them. Yes, please say your thank you from us to them, please, Pavel. That is amazing.
Yeah, sure. It's moving. It's slowly rising. The moon rising under Irkutsk, and we saw it and the total lunar eclipse during the total lunar eclipse May 26 from Australia, from such a beautiful person, beautiful amateur astronomers from Melbourne.
Yes.
Mm. And here in Melbourne, the moon's almost directly above us. Wow.
А в Мельбурне Луна почти очень-очень высоко.
Just wonderful. Thank you so much. And thank you to the public for being part of tonight's stream. Thank you for sending in your pictures and photos again. They were amazing, and for your brilliant questions.
We are so delighted by your work during and before the stream, dear friends from the Southern Hemisphere.
Thank you, Pavel. Thank you. And we must say thank you to and goodbye to our Russian friends also that were viewing us this evening. I must say a до свидания to them.
До свидания, друзья.
A до свидания, that's correct. Beautiful. Okay.
До новых встреч. Под одним небом.
Fabulous.
You can't stop looking at the moon.
No, it's too beautiful.
That is true. You can't stop looking at the moon. It is very beautiful.
Live moon, live. Huh. Great. Thank you all. It's unprecedented. It's unprecedented show from Australia and from Russia. Thank you all. Thank the team and thank the world for this opportunity.
Thank you.
We will be coming to a close shortly. It is an amazing view that we're seeing right now. We just like to leave it on for a little bit longer so you can all enjoy it and relish it before we close our show. Okay, just while we're looking at this lovely moon, witnessing this lovely moon rise in Russia, I would like to say a huge thank you to all our Russian friends who were part of this stream. Not only just Pavel, but his team also in Russia working behind the scenes. They did an amazing job. And also, I'd like to now bring up on screen everybody that was part of this, that made this happen for you all. Hello, Pavel, Jamie, Stuart. We'll bring up Andrew, Drew. Hello, Drew. Welcome. Come on in. Hello, Andrew. And where are you, Adam? You need to come on board because you have done an amazing, there you are, an amazing job tonight. You are just, it's just been wonderful. Without you, this would not have happened. Okay, so we would like to say our goodbyes and our thank you. And we'll be closing the show shortly. Good night and goodbye.